January 10th LeetCode challenge, same tree. Given the root of two binary trees P and Q, write a function and check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So we have two binary trees here, P and Q, where the binary tree, the first one is 1, 2, and 3. Second one is 1, 2, and 3. They are structurally the same and they have the same values. Return true. So you can visualize it like this. Given example 2 here, we have 1 and 2, and well, this one is 1, null, and 2. So they have the same value, but structurally they are different. Therefore, return false. So this one is they have the same amount of same values, but they're also in structurally different. So this one's 1, 2, 1. This is 1, 1, 2, and therefore return false. The constraints are the number of nodes in the tree. Both trees range between 0 to 100, and the node values ranging between negative 10 to the 4 or 10 to the 4. So there's in terms of binary trees, there's obviously the two approaches. You have a recursive case and an iterative case. I guess the simplest strategy here is to use recursion. If we check for P and Q, the nodes are not the same, or the nodes are none, and the nodes are equal, then we can just return our answer. So we just basically check all the values for the same for the child nodes recursively. So pretty much meaning that we check for P and Q are both null. Check for that first. So if P equals null and Q equals null, then here we just return true, as in they're both empty, because they're both the same. Oops. And what we're going to do next is if they're one of P and Q is null, then we just return false, because if one of them is empty while the other one is not, then they're different. Or Q is null, return false, because they are different. Next thing we want to do is if P value, the value of P, it does not equal the value of Q, then we can return false, because they are not the same values. Then we just kind of recursively go through the same situation as same tree. This time we're going to deal with the children nodes. So P.write, taking Q.write, and we do an AND with this same tree with P.left and Q.left. And run this. Okay, let's submit this. Awesome. So accepted. So basically, time complexity wise, we have a recursive case. So big O of n would be where n is the number of nodes in the tree. Since one visit each node, we visit each node exactly once. So that's big O of n for time complexity. Space complexity is also big O of n at worst case for time complexity, because if the tree is unbalanced, then we have to keep the recursive stack for n values. And let's see submission actually. Wow, this is pretty fast. Alright, that's it. Have a great day, guys.